Hello, we are the participants of Texas India Analog Design Competition from the College of SGGS INT, that is the Sri Guru Gobind Singh Ji Institute of Engineering and Technology, Vishnupuri, Nanded. Our team number is 652B and our CMT ID is 456. We have given a problem statement by the Texas Instruments as we can see in our laptop screen. It is a problem statement given over here. We are given a op-amp design of a non-inverting differentiator, which is having a op-amp of TL082CP, and we have to design its transfer function as well as we have to plot its graph as given in the problem statement, which are the frequency versus gain as well as our phase versus frequency graphs. Now we have used the software TINA, in which we have built up the circuit. You can see the TINA, a software, a simulator by Texas Instruments. We have designed the complete circuit, that is a non-inverting differentiator, in our simulator. Now we have to plot the response of frequency versus the gain, for which we have given the input as sine wave of amplitude 1 and frequency of 100 Hz. Now we have to plot the gain versus gain. We have to plot the AC analysis, that is AC transfer characteristics. Here we can see the AC transfer characteristics. Here we have given the gain versus frequency. The gain is in dB. As we can see, we have achieved the highest peak point, which is of notch filter, at nearby a 60 dB, and we have get the phase versus frequency, in which actually near the cutoff frequency we got sudden fall and 180-degree phase shift, and again a constant output, nearly constant output, as we have given in the problem statement. We can compare it with our problem statement. It is the same graph as we have achieved for the using our simulator TINA. Now we will go for the transient curve, in which we have used the square as an input, which is of frequency of 100 Hz and amplitude of 1 volt. Using analysis, we have got the transient response. First, we will see it on our oscilloscope of our. We are getting the output like an undamped oscillations, where it is giving the first pulse as a rise pulse for upper part of square wave, and similarly it is giving the negative trigger for the lower part. This is for positive pulse and this is for negative pulse. In this way we are getting the complete output. Same from hardware. Same we are getting to a hardware, that we will see later. We are getting the same output, but we will see it later. Now going to the transient response. Now for hardware work, we have used the kit AS. We have used the analog kit by Texas Instruments, that is ASL KB2010, a starter kit, in which we use the op-amp of TL082, in which we have used the spare 2, as we can see in the figure given in the pin diagrams of ASL KB kit. Now we will go to the hardware implementation of our project, our problem statement. We have used the spare 2 in our starter kit and given all the resistors as well as capacitors on the breadboard. We have designed this circuit over here using this starter kit. We are given the power supply of -10 and +10. In actual, it is showing 11.8, but in actual it is 10. We have measured in our kit. Now giving the power supply from a function generator. We have used a lot of function generator here for the proper output. We have taken the frequency, where the frequency variations as well as amplitude variations are taken over here, and now we have taken our outputs on the digital storage oscilloscope, that is DSO, and we have got the transient curve over here, as we have seen in the simulator as well as in the problem statement. We have got the perfect output, that is for positive pulse. We have our pulse is starting from the positive, and for negative pulse, output is starting from the negative. You can see over here. Now, dealing with the problems we have faced in the kit as well as our starter kit. The first problem is that we have a lot of distortion as well as noises in our output, the same output we are getting a lot of noise and distortions in our output. The next problem we have faced is the setting the voltage, the input voltage from the function generator. We are getting a lot of problems for getting the voltage output which is below the saturation. So we have to use a lot of function generators. We have changed nearly 3 to 4 function generators over here for getting the perfect output. Third one is that getting the phase response. While plotting the phase response, we are getting phase response as well as input output curve. We have taken these readings. So here the input voltage ranges, output voltage ranges, and phases. But in actual, we have given with the phase diagram as given over here. We have faced a problem while plotting this same diagram. We got this curve completely according to our problem statement, as well as we got the same output over here. The same graph is plotted from 90 degree to 65 degree. This is a sloping curve we got from the practical output. The sudden fall, we also got it at the cutoff frequency, but we are facing the problem to plot this graph. In practical, we are not getting the perfect output of this curve. This part of curve is not getting in actual. We are getting the different outputs. So we are facing the problem of plotting this graph. Otherwise, we have got all the outputs in our as well on simulator as well as on practical. In this way, we have completed this phase 1A of TI analog design competition. Thank you. Thanks a lot from our college. I would like to thank our mentor, Dr. S.N. Talwar sir, as well as our college which have provided us a kit and the facilities for this competition. Thanks a lot to Team Texas Instruments too.